Since time is limited, let's get started learning just enough computer science to be a better self-taught data engineer or data scientist. Goal of this talk, I want to share my learning journey from being a business graduate to become a data scientist, data engineer. At the same time, I will discuss some computer science concepts that have been most beneficial for me to become a data engineer. My goal for me is to maximize your output at the same time minimize your learning time. So this talk is mostly for people with limited computer science education, and you're also on a journey to become a self-taught data scientist, data engineer. A shameless plug. St. Jude has helped to push survival rates for catastrophic childhood cancers from 20% to about 80%. And what's amazing is we don't bill patients. So please consider donation. So here are the topics I'm going to cover today. Hopefully I'll get to finish all of them within 15 minutes. Command line, I think, is the most important concept I've ever learned in my data engineering journey. I remember when I first started doing data science, I was doing fine with just two commands. One is to start Jupyter Notebook, and the second one is to pip install Python packages. Until one day, I had to train a model that doesn't fit into the memory of my laptop. Or if you want to deploy a real model on a cloud service provider's server, or you want to do any of web dev, version control, or even containers. Command line can be confusing, so let's look at common patterns of a command. Let's look at an example. Pip install dry run pandas. So pip is the actual command you want to execute. Install is the subcommand in this case. It's often used to organize and structure command in a way that's user-friendly and easy to remember and understand. And dry run is the option. Of course, it's optional and modifies the behavior of the command. In this case, dry run just means pip will show you what it's going to do instead of actually install the package. Pandas is the actual argument. Now that you know what a command usually looks like, let's look at what an actual command line interface looks like. Some of the most commonly used command is touch, which creates a new file. ls will list the files and directory in your target directory. And mkdir is to make a new directory. And of course, cd, which means change directory, where you can jump from one directory to another directory. And those 3 or 4 commands are probably will cover 50% of a data scientist's daily usage of command line. So for now, I think we're good on the command line. How can you make your script behave like a app software? Introducing argparse. Argparse is the built-in Python package that let you build command line interface into your Python scripts, and it's easy to use. You might have noticed I added a shebang into my Python file. It just tells the system to use the Python interpreter to execute the script. What's even more awesome is with these descriptions added to your argparse, it automatically populates documentation for your command line utility as long as you execute your script with -h. And if you notice over here, your script now behaves like a software. Next, I'll quickly mention Python virtual environments. There are many options regarding virtual environment. I mostly use Conda. Another thing I want to mention is the which command. Sometimes you can use which to quickly pinpoint or locate the problem with your environment configuration. Git is another essential tool you must have under your belt for securing a data science job. But here are 2 recommended tutorials you can look at. Just remember Git and GitHub are 2 very different things. Now let's talk about computer networks. It sounds really intimidating because this image always comes to my mind when I think about computer networks. But actually, instead of focusing on those, we should focus on one single message that is sent to one computer to another computer. Just like writing a letter and envelope, you must follow certain rules for the post office to deliver your letter correctly. The messages on the internet follow Internet Protocol, and the addresses on the message are called IP addresses. Just like a letter, you have a from IP address and you have a to IP address. Now, in real life, letters are not always enough because sometimes you need to send packages. With packages, courier usually needs more information, like the dimension of your package and the weight of your package, meaning a more complex protocol needs to be invented. Similarly, in computer networks, when we have more complicated applications, UDP and TCP are invented on top of IP. Now, as you can see on the right side, TCP packets literally just have their own headers sit inside the data payload of IP packets. Of course, there is more to it, like handshakes, acknowledgements, but for now, this is good enough for us to build an intuition about the packets transporting along the cables between different computers. Here is an example message, or TCP packet, if you will. As you can see on the left side, it's the IP header, as we mentioned earlier, and I want you to focus on the source address and destination address. Right? You have your source IP and destination IP. On the right side, which is the TCP header, where you have source port and destination port. Now, I always had this question before I know what port is. Like, why would you have a port? Your computer will assign a port for different applications. Say your Teams will be running on port A501 and Slack will be running on port A502, so that when a TCP packet comes, it will specify which port it's for and the packet will be routed to the correct application. Here is an example payload of a TCP packet. Although over here is a HTTP request, but it literally can be anything. Just in this case, it happens to be an HTTP request, which is something we can talk about later about HTTP request. And HTTP requests and responses are how your browser can display a web page in front of you. For example, if you think of your browser as the client here, a Google server as the server here, your browser will send a HTTP request and Google server will process that request, sends back the web page, and your browser will process the web page and display it in front of you. I want you to focus mostly on the first verb of the HTTP request. A GET request, as the name suggests, it will retrieve data from a server. Basically, that's what happens when you hit enter after typing google.com in your browser. And another very common request is post. Again, like the name suggests, you post something to the server, often causing a change in state or side effects on the server. A good example is when you hit submit after filling out a form on the web. And there are other different types of request methods, but get and post are good enough for you to build an intuition around HTTP requests. Homepage is sent back an HTML file, which is correct. But I want you to focus on the 200 OK here, mostly the 200. That's a status code It basically informs your browser, the client, of a general result of the request. And that's it. Usually 200 is very common, and 400 is another very common response. I believe everybody has seen 404 not found. And next, let's quickly learn how to build our own responding server and make requests to that server using Python. I would highly recommend look at Flask, especially for data scientists. These are already good enough to build a demo to showcase your machine learning model. With this, you already can deploy this to Azure or Google Cloud quickly. And don't get intimidated by the word deploy. It literally just means copy your files to another computer and configure that computer's environment and run these files on that computer. Okay, so don't focus on the syntax, but I want you to focus on the method, meaning this address will only take get request, and this address or this endpoint will only take post request. Now, if I go to my local host, you'll see my API is working indeed. And to get data from API using Python, it's as simple as Flask. Just import requests, get the correct URL, and do a get. Here I use get because this endpoint only takes get request. And over here in this endpoint, I use post because this endpoint only takes post requests. And you can see I even sent in data of the name Jian, and it will respond hello. I also want to quickly show you what your browser does after getting the response. So you can see on left and right, the only difference is the H1 tag. If you're not familiar with H1, it's basically just another protocol where your browser follows that. When your browser see H1 tag, your text will look like this. If we don't have H1, it's just plain text. Next, I also want to quickly show you how you can pull information out of a web page instead of an endpoint. So for example, in this case, if our web page has this H1, we can use Beautiful Soup to extract that information out of H1. And yes, that's essentially how web scraping works. So now, with all the tools under your belt, what can you do next? You can sign up for my course no, I'm kidding. I don't have a course, but maybe I should. So really, what's next? I would do a project and more projects. Here's an example end-to-end project you can do. Here, I will also recommend learn MongoDB as an example of NoSQL DB. That's usually commonly used. And finally, you can build an UI. Here, I would recommend Streamlit. And here's just a quick example of your possible machine learning app. Nothing fancy. You just need a text box and output your prediction. And this app, literally, it only takes 8 or 9 lines of code. And that's it. And here are some more data engineer topics you can look at. If you're interested in similar content, you are very welcome to follow the Self-Taught DE account over here. So, yeah, thank you very much. Here is the references and credits. Thank you very much.